Okay, today we're going to look at the features of quadratic graphs and just how to find them. Now there are a few, and here's a couple of one example we'll look at. So we're going to look at the missing features. The first thing we're going to do with this quadratic, and as you can see that curve shape, which in this instance is an unhappy, it's like a frown, is the form of a parabola. Now it's reflected in the x-axis, which means basically it's flipped over. Instead of a happy, which is a nice shape like that, it's been flipped over to make it a sad, or reflected in the x-axis. These things have what's called a maximum point, so that is we reach our highest point at this spot, whereas the happies have what's called a minimum. So for part A, this parabola is actually a maximum. Looking at part B, the coordinates of the turning point. Now the turning point is simply that, where the graph actually flips over from going up to going down. So our turning point is this one here. It's also known as the vertex or vertice. Thirdly, the coordinates of the y-intercept. Now the graph cuts the y-axis at this point here. And the x-intercepts in part D, as you can see, it intercepts the x-axis both at this point and at this point. Now it's not unusual for x-squared graphs to actually have two intercepts. On occasions they actually have just one. That might be where the graph comes in, touches the x-axis and then bounces back off, and other times they don't have any at all. So for instance, we might have our graph sort of hovering in space and not touching the x-axis. Despite the fact that these two graphs I've just drawn in red don't have this one doesn't have any x-intercepts and this one only has one, they typically will have a y-intercept as well. Now finally, our axis of symmetry is simply that line upon which, if we were to fold our graph in two, going along a vertical line, where would they meet up? So I've just drawn that dotted line in. If I was to fold along that dotted line, hopefully both sides of my graph, this side and this side, would meet perfectly. So that makes the dotted line my axis of symmetry, and the equation for that is x equals -2. Okay, you'll notice that the x-coordinate of the turning point also works as the axis of symmetry. Thanks very much.